morning students. So in this class we are going to see the definition of convolution of two functions. So in the previous class we have seen about the inverse, the transform and its properties. So now let us move on to the definition of convolution of two functions. Suppose if we are given two functions f of n and g of n, the convolution is defined by the symbol star. So f of n star g of n is given by summation k equal to 0 to n f of k and g of n minus k. That is, you have to replace the first function f of n to be f of k, and the second function g of n as g of n minus k. So now let us see a problem using this convolution theorem. So the question is, using convolution theorem, find z inverse of 8z square divided by 2z minus 1 into 4z plus 1. So let me take the left hand side as z inverse of 8z square divided by 2z minus 1 into 4z plus 1. So equal to z inverse of 8z square divided by, so let me take this 2 outside from this and let me take this 4 outside. So you get 2 into z minus 1 by 2 and 4 into z plus 1 by 4. So that 2 into 4 is 8, that will cancel with this 8. So we are getting z inverse of, z square divided by z minus 1 by 2 into z plus 1 by 4. So I am going to split this term into two functions, that is f of n into g of n. So it is equal to z inverse of, so this can be written as z divided by z minus 1 by 2 into z divided by z plus 1 by 4. So this is our f of n and this is our g of n. Now let us use our convolution formula. So what you get? So z inverse of z by z minus 1 by 2 star z inverse of z divided by z plus 1 by 4. So we know that z inverse of z by z minus a is nothing but z of a power n. So here our a is 1 by 2. So you get 1 by 2 power n star. Here our a value is minus 1 by 4 power n. So this is our form f of n star g of n. Now let us use the formula. So that is given by summation k equal to 0 to n. So first n we have to replace by k, that is 1 by 2 power k, and second n we have to replace by n minus k, that is minus 1 by 4 power n minus k. So from this equation we are going to take the terms which are all independent of k, you have to take it outside, that is minus 1 by 4 power n, let us take outside. So you get summation k from 0 to n 1 by 2 power k into minus 1 by 4 power minus k. So which is equal to minus 1 by 4 power n summation k equal to 0 to n 1 by 2 power k. So I am bringing this minus 1 by 4 power minus k to the denominator. So you get minus 1 by 4 power plus k. So which is equal to minus 1 by 4 whole power n summation k equal to 0 to n. So both the numerator and denominator are having the same power as k. So let me divide this. So 1 by 2 into minus 4 by 1 whole power k. We can rewrite this equation as this. So 2 and minus 4 gets cancelled 2 times. So the answer is minus 1 by 4 power n summation k equal to 0 to n minus 2 power k. Next we are going to expand the summation. So you put the value for k. So what you get? Minus 1 by 4 power n into, when k equal to 0. So minus 2 power 0, anything power 0 is 1. Plus when k equal to 1 you get minus 2 power 1. When k equal to 2, minus 2 the whole square plus etc. Plus when k equal to n you get minus 2 power n. So this is our form 1 plus r square plus etc. r power n. So we have one formula for this. What is the formula? So 1 plus r square plus etc. plus r power n is equal to 1 minus r power n plus 1 by 1 minus r. So this I am using here. 1 by 4 power n into 1 minus r power n plus 1. Our r is minus 2. So minus 2 power n plus 1 divided by 1 minus r. That is 1 minus of minus 2. So 1 minus of minus 2 is 1 plus 2, that is 3. So minus 1 by 4 power n into 1 minus of minus 2 power n plus 1 by 3. So this is our answer. So hope you understand this problem. Thank you.